I am your PobrengInhinyero. Let's talk about infiltration. Infiltration is the process by which water on the ground surface enters the soil. Infiltration rate in soil science is a measure of the rate at which soil is able to absorb rainfall or irrigation. It is measured in inches per hour or millimeters per hour. The rate decreases as the soil becomes saturated. If the precipitation rate exceeds the infiltration rate, runoff will usually occur. The rate of infiltration can be measured using an infiltrometer. The double-ring infiltrometer is suitable for almost any type of soil. It is applied in irrigation and drainage projects, groundwater and infiltration basins, in optimizing water availability for plants and to determine the effects of cultivation. It consists of 3 pairs of inner and outer rings, a driving plate, an impact-absorbing hammer, measuring bridges, and measuring rods with floats. Specific learning outcomes. At the end of the topic, the students should be able to define infiltration, discuss the factors affecting infiltration and infiltration measurements, perform computations involving Horton model, Phillips equation, and Green, amped model. Before we proceed, if you are new to this channel, please click the subscribe button and hit the notification bell to keep you updated. Factors affecting infiltration. 1. Soil type. This include texture, structure, and hydrodynamic characteristics which influenced by capillary forces and absorption rate. 2. Soil coverage. Like vegetation for instance has positive influence on infiltration through increasing the time of permeation in soil. 3. Topography and morphology of slopes. 4. Flow supply. This include rain intensity and irrigation flow. 5. Initial condition of soil humidity. Soil humidity is an important factor of infiltration regime. The infiltration regime evolves differently in time for dry or wet soils. 6. Soil compaction. The use of hard agricultural equipment can have consequences on the surface layer of soil. Measurements of infiltration. We have single tube infiltrometer and double ring infiltrometer. Hortons equation. Named after Robert E. Horton, Hortons equation is another viable option when measuring ground infiltration rates or volumes. Horton showed that when the rainfall rate, I, exceeds the infiltration rate, F, water infiltrates the surface soils at a rate that generally decreases with time, that is I greater than F at all times. The rate of infiltration depends in a complex way on rainfall intensity, soil type, surface condition, and vegetal cover. The capacity decreases with time and ultimately reaches a constant rate, caused by filling of soil pores with water, which reduces capillary suction. Sand will generally infiltrate more volume at a higher rate than clay soils. It is an empirical formula that says that infiltration starts at a constant rate, F, O, and is decreasing exponentially with time, T. After some time when the soil saturation level reaches a certain value, the rate of infiltration will level off to the rate Fc. The formula is where Ft is the infiltration rate at time t, F, is the initial infiltration rate or maximum infiltration rate, inches per hour. Fc is the final or equilibrium infiltration rate after the soil has been saturated or minimum infiltration rate. K is the empirical constant specific to the soil, per hour. The other method of using Horton's equation is as below, which can be used to find the total volume of infiltration, Ft, after time t. The formula is. Let's try sample problem number 1. The initial infiltration capacity F, of a watershed is estimated as 1.5 inches per hopper and the time constant is taken to be 0.35 per hours. The equilibrium capacity Fc is 0.2 inches per hour. Use Horton's equation to find the values of F at t equals 5 minutes, 10 minutes, 30 minutes, 1 hour, 2 hours, 3 hours, 6 hours, 8 hours, 10 hours. B. The total volume of infiltration over the 10-hour period, and C. Develop a plot of infiltration versus time. Solution. Convert the time in minutes to hour. Substitute the given values to the formula. Compute using your calculator. Please check the answer. Pock Garner. If the answer given the figure is wrong, just dial 912. Char Lang. Then, calculate the capacity over the 10-hour period, and the answer is. Lastly, plot the infiltration versus time. You may enter the data in Excel. Then, evaluate the curve. What have you noticed in the graph of infiltration versus time? Moving on. The next model is the Phillips model. Philip proposed a method of resolving the vertical infiltration for certain initial and boundary conditions. This model has introduced the notion of sorption, which represents the soil capacity to absorb water when the flow is produced only under gradient pressure. The formula is, where I/T equals infiltration rate in centimeter per second. S equals sorption in centimeter per second raised to 1/2. T equals time in seconds. A equals the gravity component, depending on hydraulic conductivity on saturation in centimeter per second. And for horizontal infiltration, the gravity gradient is not involved. Infiltration will have the following expression. Lastly, we have Green and Amped infiltration equation. Green and Amped equation is used to obtain the volume of water, Fs that will infiltrate before surface saturation is reached. The formula is, until it has infiltrated, the rate of infiltration is equal to the rainfall rate. After that point, surface saturation, the rate of infiltration is equal to. The equation depicts the relationship between the infiltration rate, that is F in inches per hour, and the cumulative depth of water infiltrated into the soil, F in inches. Hydraulic conductivity, Ks in inches per hour, that transmits water downward based on hydrostatic pressure and is accompanied by suction head or psi in centimeter. During infiltration, the suction acts in the same direction as the water flow and pulls water downward. This can be measured by the instrument called a tensiometer. Solution of the Green and Amped equation requires the estimation of three parameters: the vertical saturated hydraulic conductivity, Ks, the moisture deficit, Md, and the suction head, psi. Moisture content is defined as the ratio of the volume of water to the total volume of a unit of porous media. Moisture deficit, Md, is equal to the difference of saturated moisture content, theta sub S, and initial moisture content, theta sub I. The formula is, where Fs equals the amount of water that infiltrates before water begins to pond at the surface in inches and Tp equals the time it takes to have water begin to pond at the surface in hour. Let's try sample problem number 2. Solve the volume using the Green and Amped equation for the following soil properties. Given Ks equals 1.97 inches per hour, theta sub S equals 0.52, theta sub I equals 0.33, psi equals 9.5 inches, I equals 7.8 inches per hour. Also, develop a plot of infiltration rate, F versus infiltration depth, F solution since all the units are consistent. Substitute the given values to the formula. Compute using your calculator. Please check the answer. Poc poc. Gannard. If the answer given the figure is wrong, just dial 912. Again Char Lang. Fs is equal to. Then, solve for the values of F. Assume the values of depth, F say 1 inch, 2 inches, 4 inches, 8 inches, 10 inches, 20 inches. Plot the curve and evaluate. Enter the data to Excel to generate your curve. Let's try sample problem number 3. What's the total infiltration in cm from a 3-hour rainfall event with a 0.8 cm per hour intensity? Calculate the time it takes to have water begin to pond at the surface. The soil's Ks equals 0.045 cm per hour, theta sub I equals 0.3 and theta sub S equals 0.6, and psi equals 21 cm. Thanks for watching. This is your PobrengInhinyero saying, bye-bye and have a good day.